Okay, for the second lecture in Chapter 8, we're going to look at the concept of polar and nonpolar bonds and also how these types of bonds can create hydrogen bonding, which is important to understanding the properties of water. So first, let's look at what we know about water. Water is H2O. We've, throughout the semester, looked at different ways to represent molecules, in this case, water. We can have our Lewis dot structures, look at different bond angles and space-filling representations. Again, these are all the same molecule, just different ways to view water. Water has unique properties. Some of those unique properties include that it's a liquid at room temperature. Most molecules that have similar molecular weights to water are gases at room temperature. So there is something going on with interactions of water molecules that allow it to be a liquid at room temperature. It also requires a lot of energy to change from a liquid to a gas. You have to reach about 100 degrees Celsius in order for this to happen. Again, this is not common for molecules the size of water. Another unique property of water is that the solid takes up more volume compared to the liquid. For most molecules, when you go from the liquid to the solid state, it takes up less volume, it's more condensed, and also ice floats on water. This is a result of some of the intermolecular forces in water, which we can understand by first looking at electronegativity. Electronegativity is a measure of an atom's attraction for electrons it shares in a covalent bond. So water is a covalent molecule. They are covalent bonds. Electronegativity looks at how those electrons in the bonds are distributed. So electrons are not shared equally in the bonds for most molecules. And the electronegativity just tells you how likely one of the molecules is to attract that electron. So if we look at the electronegativity of water, it's 2.1. Of oxygen is 3.5. Oxygen has a higher electronegativity compared to the water. This means that that oxygen is going to have higher density of that negative charge. It attracts those electrons. Remember, electrons is they have a negative charge. So now let's look at this concept of electronegativity in the bonds of water. We said that oxygen has a higher electronegativity. The electrons are attracted to that oxygen. We represent this with a partial charge. So oxygen has a partial negative charge where hydrogen has a partial positive charge. This is just saying that the electrons in this bond are attracted to the oxygen to a greater extent compared to the hydrogen. When you have electrons that are not equally shared, we call these polar covalent bonds. So water has polar covalent bonds, and as a result, that electron density is not evenly distributed throughout the molecule. We can talk about polar bonds. We can also talk about polar molecules. So a polar bond is when the electrons are not equally shared between two atoms in the bond. In a polar molecule, that it's just saying that that molecule has charge distribution throughout the molecule, that the electrons are not evenly shared throughout that molecule. So again, if we look at water, this is a polar covalent bond. Water we know is covalent, and it's polar because the electrons are not equally shared. Hydrogen gas, H2. This is an example again of a covalent molecule. But in this case, it is nonpolar. So the electronegativity of hydrogen is going to be equal since you have two hydrogen molecules, identical molecules. When they're equal, it means that those electrons are going to be shared, equally distributed in that bond. If we look at something like sodium chloride, here we have a metal and a nonmetal. As a result, we have an ionic bond. When we're talking about ionic bonds, we don't talk about polar and nonpolar. In an ionic bond, there is a large charge difference. This charge difference, or the electronegativity difference, is larger than what you see in most covalent bonds. And this is why we have some of the properties of ionic compounds in water. So why do we care about polar and nonpolar bonds? Well, one of the reasons it's important when we're talking about water is that the polarized bonds allow hydrogen bonds to occur. A hydrogen bond is an intermolecular bond, meaning it's an association between two different water molecules. This is different than our intramolecular bonds, our ionic or covalent bonds. Those are bonds between atoms within a molecule. A hydrogen bond is an intermolecular bond. It is an association between two water molecules. Hydrogen bonds occur as a result of the electrostatic attraction between an atom bearing a partial positive charge in one molecule and an atom bearing a partial negative charge in a neighboring molecule. So we said that the hydrogens have a partial positive charge. Oxygen has a partial negative charge. We know that a positive and negative attract. So as a result, you get this intermolecular bond known as a hydrogen bond in water molecules. A hydrogen bond only occurs when hydrogen is attracted to oxygen, nitrogen, or fluorine atoms in another molecule. So hydrogen bonds only occur if you have a hydrogen in one molecule attracted to an oxygen, nitrogen, or fluorine in another molecule. Again, this is a intermolecular bond. These are weaker than our intramolecular bonds. So the hydrogen bond, the strength of that bond is about 1/5 the strength of the covalent bond. But these hydrogen bonds are why we have some unique properties of water. The hydrogen bonds hold those water molecules together much more than molecules that don't have hydrogen bonds. And this results in it being a liquid and not a gas at room temperature. So in order to go from that liquid to that gas, we have to provide more energy to break those hydrogen bonds so that gas can, or so the water can go from a liquid to a gas. This is why it has a high boiling point. We have to add more energy, more heat in order to get that transformation from a liquid to a gas. The hydrogen bonds also explain why the solid is less dense, takes up more room compared to the liquid. What we have over here is a diagram showing the hydrogen bonds in a solid. Every molecule in ice, or the solid form of water, are associated to the other molecules using hydrogen bonds. And this results in a very structured formula, a structured arrangement of those water molecules. In the liquid form, some of these hydrogen bonds are broken. We have more energy, more heat in the liquid form, and as a result, some of these molecules can move into these voided spaces, resulting in the molecules being more tightly packed. And this is why water in the liquid form takes up less volume compared to the solid state.